Let's talk about integration using trigonometric substitution. Here's our problem for today. What is the integral of the square root of 1 minus x squared dx? You can pause the video and see if you can solve this problem. Okay, let's solve this problem together. This is a problem that is sent by one of our page followers. Notice that in this problem, under the radical symbol is the expression 1 minus x squared. For families of functions that look like this, the best integration technique is to use trigonometric substitution. And recall that in our trigonometric identities, cosine squared theta is equal to 1 minus sine squared theta, which fits perfectly to the form of 1 minus x squared. So what we are going to do is we're going to perform these substitutions. First, we let x be equal to sine of theta, and dx is equal to cosine theta d theta. Also, from x equals sine theta, it follows that theta is equal to sine inverse of x, or theta is equal to arcsine of x. And at the right side, solving for d theta, we have d theta equals dx over cosine of theta. Aside from these substitutions, we need to recall also the following double angle identities. These are the prerequisite knowledge that we need to remember in order to find the integral of this given function. So let's begin. Because of our substitution for x equals sine theta, instead of x squared, we now substitute sine squared theta for x squared, because x is equal to sine theta. Then we have this expression for dx. dx is equal to cosine theta d theta. So we replace dx with cosine theta d theta. Now recall that 1 minus sine squared theta is equal to cosine squared theta. So using our trigonometric identity, we replace this 1 minus sine squared theta by cosine squared theta. All the rest are copied. Now for this to work, we need to establish that the domain of our angle, theta, must be from the interval negative pi over 2 to positive pi over 2, or from negative 90 degrees to positive 90 degrees. And with that as our condition, then we can now evaluate this part, the square root of cosine squared theta, as the absolute value of cosine of the angle theta. But since we restrict our domain and recalling our unit circle, the angle negative pi over 2 is here, and positive pi over 2 is this part. Notice that the cosine in this interval, that means this x value, is always positive. So there's no problem for us if we remove this absolute value symbol. So this one is just equal to cosine of the angle theta, given that our theta is restricted to this domain. That is because cosine is the x value in our unit circle, and the x value is always positive when the interval of theta, or the angle, is from negative pi over 2 up to positive pi over 2. And so we can now evaluate this square root of cosine squared theta as cosine theta, and multiply by another cosine theta here. We have cosine theta times cosine theta equals cosine squared theta, and copy the differential d theta. At this point, we need to know what is the value of this, and also notice that we are writing here with respect to the angle theta, whereas our given is in terms of the differential dx. So we want to simplify now this expression in terms of the variable x. So first, from our double angle identity, we have this identity, cosine of twice the angle is equal to 2 cosine squared of the angle minus 1. So that is what we have here. And since in this expression, what we have is cosine squared of the angle theta, then in this identity, let's solve for cosine squared theta. We add 1 to both sides to get cosine of 2 theta plus 1, and we divide by 2 to get cosine squared theta. And then we can separate the two terms as cosine of 2 theta divided by 2 plus 1/2 equals cosine squared theta. And so by symmetric property and by applying the commutative property of addition, we now have this form for cosine squared of theta. So using now this value, substitute that to this form. The integral of cosine squared theta d theta is now equal to the integral of this part, 1/2 plus 1/2 cosine of 2 theta d theta. This part is easier to integrate than cosine squared theta. And so, applying now the rule for integration, we now have the integral of 1/2 d theta is equal to 1/2 theta, and the integral of this part is 1/4 sine 2 theta plus a constant c. Now to arrive at this, we perform what we call as the u substitution. Let me show you how we arrive at this 1/4 sine of 2 theta. So from the integral of cosine of 2 theta d theta, we let u equals 2 theta. It follows that du over d theta therefore is equal to 2. And solving for d theta here, d theta is equal to du over 2. And then using these values, we now have the integral of cosine of u du over 2, because our d theta is du over 2. And then we can factor out the 1/2, so you have 1/2 times the integral of cosine of u du. Then let's continue here. We have 1/2 times the integral of cosine u, which is sine u, plus c. And so the integral of cosine 2 theta d theta is equal to 1/2 sine of u, where u is equal to 2 theta plus c. But since you have this other factor of 1/2, 1/2 times this 1/2, that gives us this 1/4. So that's the reason why we now have 1/4 sine of 2 theta, which is this part, plus c. We arrive at this by this u substitution. But remember that what we are integrating is the square root of 1 minus x squared dx. And at this point of our solution, this is the value that we have so far. But what we have here is in terms of theta, in terms of the angle theta. So we need to go back again to our prior substitutions. So remember that from our prior substitution, we have sine of theta is equal to x. So that means this sine of theta, we can replace with x. This 1/4 times 2 becomes 1/2. And this theta is equal to arc sine of x. And so, we now have this next line. 1/2 replace theta with arc sine of x. 1/4 times 2 is 1/2. Sine of theta is x. Copy cosine of theta plus c. So there's just one problem left with us to resolve. We need to know what is this cosine of theta. Everything else now is in terms of the variable x. So let's recall our right triangle. What we are given here is sine of theta is equal to x. So if this is our angle theta, the sine of theta is x, that means the opposite is x. And if we have a unit circle, this radius is 1. Since what we have here is a right triangle, using the Pythagorean theorem, we'll be able to find the length of this side. And that is the square root of 1 minus x squared. So since we know the length of this side from Pythagorean theorem as the square root of 1 minus x squared, then the cosine now of this angle theta must be the square root of 1 minus x squared over 1, which is simply the square root of 1 minus x squared. So that brings us now to this result. Instead of cosine theta, we now replace that with the square root of 1 minus x squared. Everything else are just copied. And since everything now here is expressed in terms of the variable x, we now therefore say that the integral of the square root of 1 minus x squared dx is equal to 1/2 times the arcsine of x plus 1/2 x times the square root of 1 minus x squared plus a constant. And this completes now our solution. In our next video, we use this result in order to find the numerical value of pi using calculus technique, which we call as definite integration. So we'll see you in our next video.